So this is the first one you sent me. It says, suppose that 31% of people own dogs. If you pick two people at random, what's the probability that they both own dogs? That's going to be the probability. We'll say one has a dog, person one and person two have a dog. So the probability the first person has a dog is 31% or 0.31. And since these events are independent, you having a dog has no effect on me having a dog. The probability of the second guy is also 31%, and we multiply because it's an and probability. So we're just going to get 0.31 times 0.31. This thing turns on. There we go. 0.31 times 0.31. So we get 0.0961. And that's it for that guy. All right, now this says, giving a test to a group of students, the grades and genders are summarized below. Find the probability that a student was not a male that got a C. So if it's looking for not something, sometimes it's easier to find the probability of being that thing and subtracting it from 1. So if I'm looking for probability of male and C, I'm doing not male and C. That's the same thing as 1 minus the probability of a male and C. So of all the people, of all 68 people, how many were males with C's? 14 out of 68. So this is just going to be 1 minus 14 out of 68. So we end up getting 54 out of 68. And that reduces. If you're not good at reducing fractions, the calculator will do it for you. 54 divided by 68. Math, enter, enter. 27 out of 34. Okay. And the last two. This is basically they test 5 CDs at random, and if at least one are defective, they reject the entire batch. So this is saying find the probability of rejecting the entire batch. So that happens when there's one defect. That happens when there's 2 defects. That happens when there's 3 and up to 5. So you could do it this way. You have to find the probability of 1 defect, 2 defects, 3, all the way up to 5 defects. Or you can say, well, what's the complement of that? What's the only other outcome I can have besides 1, 2, 3, 4, or 5 defects? Well, that's going to be the probability of no defects. And if this is the only other option that we have, then to find the probability of the original thing, I'm just going to do 1 minus that. So this is going to be ugly, but we have 1 minus. The probability of the first one is not defective. Well, there's 6,500. 80 are defective. That means we have a 6,420 chance out of 6,500 that the first one's not defective. I'm going to put this in parentheses. And then we're going to multiply. The probability the second one's not defective. Well, if this one's not defective, that means there's 6,419 left. And this is 6,499 times 6,418 times 6,498 times 6,417 divided by 6,497. And the last one, 6,416 divided by 6,496. Put that in your calculator. Just be extra careful because you got a lot going on here. I'm just going to do the brackets first. So I have 6,420. I'm just multiplying the numerators, okay? 6,440 times 6,419 times 6,418 times 6,417 times 6,416. That's my numerator. Now I'll do the denominator, 6,500 times 6,499 times 6,498, 6,497, 6,496. I'll just take that top guy, that divided by that, and my answer is going to be 1 minus that. It's a lot, but so my answer is going to be 0.0600. This says rounded to 1 decimal place accuracy. Oh, as a percent. So this would just be 6.0%. Okay, this last one's done the same way. It's just instead of collecting CDs, you're collecting blood samples. So you have 3 samples here, and it says we reject the samples if it's tested positive. Find the probability of a positive result for 3 samples combined. So that means at least one. So we can see the probability of one sample, one positive. That's going to be plus the probability of 2 positive, plus the probability of 3 positive. But again, that's time consuming, so I'm just going to do 1 minus the probability of no positive. Well, what's the probability of no positive? Well, the probability that the first one is negative is the complement of this, is 0.92. And there's 3 samples, so I'll just do 0.92 times 0.92 times 0.92. 0.92. I'll do 1 minus that. I get 22.13 or 22.1.